figuring out what went wrong or why
Yeah,
something didn't work.
if it fails, it's okay, but you gotta know how to learn from your failure or how to debug the thing that doesn't work.
Mm-hmm. Welcome to the LabVIEW Experiment. I'm your host, Sam Taggart from SAS Workshops. If you're a developer looking to unlock your potential and take your skills to the next level, then look no further. From freeing your imagination and experimenting with new ideas and workflows, to exploring aspects of software development you've never even considered before, I'm going to help you grow your craft so you can approach your work like an artist and have more fun with what you do. In my 15 years working with and training developers, I've helped dozens of individuals and organizations embrace a growth and learning mindset that allows us to overcome challenges and embrace failure as the essential learning experience it is. If you're ready for the philosophies, strategies, tips, and tricks that will unlock your creativity, then it's time to get to work. All right, so I am here today with Stefan. Let me pronounce your last name correctly. Lemmens?
That's correct.
Perfect. Okay. I always want to make sure I'm pronouncing people's names correctly. I thought I knew that, but I just want to make sure. So we've known each other for what, 3 or 4 years now? At least?
Yeah, about that.
Yeah. Stefan is a LabVIEW champion.
Yeah, recently. Yeah.
Recently, yeah. Well, a year now, so it's been a little while. Stefan is also a member of my mastermind group.
Yeah, for a couple of years. How long are we?
Yeah, you're one of the founding members.
Yeah.
So, yeah, that's at least,
for
I think we started in 2020, so it's been at least 2 years. Maybe even 2019.
Yeah, I
Did we
guess
start
so.
before the pandemic? I don't remember. Anyway, so I don't want to turn this into a mastermind ad or anything, but can you say a few words about that before we get started? Like what you get out of it? Or
The mastermind? Yeah, it's a nice group of people where we discuss a lot of stuff, software engineering stuff, LabVIEW stuff, business stuff. And we have meetings twice a month, and I always end up with some small idea like I want to try that or I want to try that. So it keeps on inspiring.
Yeah, and actually the interesting thing about Stefan is in the beginning you were paying out of your pocket, right? And then your company saw so much value in it that they then went and you agreed to get them to reimburse it. So that's pretty cool.
Yeah, really, I didn't want to miss the start.
Yeah. There's also a lot of other cool people in the LabVIEW Mastermind. I mean, there's several LabVIEW champions.
Yeah, the group changed a little bit over time, but it's really worth.
Yeah, cool, awesome. So one of the things that you've talked about in our LabVIEW Mastermind that I kind of want to dive into is using some external tools, particularly Artifactory and Conan. So can you tell me a little bit about what the problem is that you were trying to solve and how you found those tools and how they helped you?
That's a good starting point. The problem we try to solve is having dependencies in the user lib, system-wide project dependencies. And more people have been struggling with that the last years because at the last GDevCon there was a presentation on using Git submodules to solve the problem. At some GLA summit, there was a presentation from Composed Systems, how they solved the problem. And all those pieces came together with us, and then we tried to solve the same problem for us with a custom tool or something like that. And then we also have some C++ colleagues, and one of them said, like, we're using Conan, which is a package manager, a very good package manager, but for C. But it can also handle binaries. Maybe you should try that. And it turned out to be very easy to use, well documented. Wrote a LabVIEW extension to Conan. And now we create packages, store them in our repo, and then Conan also gets them back and installs them as project dependencies and not in the user lib anymore.
So it's inside a subfolder under your project.
Yeah.
And then you just exclude that from Git or something?
Yeah,
and then
it's
you have
excluded.
A manifest or something?
The manifest is the Conan file.
Okay.
So Conan file is just a text file that says, these are your dependencies. And Conan handles it very well.
So then if I'm a new developer, I just clone your repository and I run some Conan command and it installs
one command, Conan install.
Okay.
That's it. You get it from Git, Conan install, and everything should be ready.
So then that would in some ways be the equivalent of a VIPC file from VIPM, except that it doesn't put it in userlib, it puts it inside your project?
The thing is, when we started with this solving this problem, JKI also announced Dragon.
Yep.
And it's exactly that what we're also trying to solve. So maybe Conan isn't the way to go for the LabVIEW ecosystem, but it's how we solved our problem in the meantime.
Yeah. No, well, it's very interesting when you say that like lots of people are trying to solve the same problem, because at GDevCon NA, we had like 2 presentations, and I don't know if you've seen them, but you probably know Casey has his Bowser the browser thing. And also, you know that Enrique has his Panther browser, and they both solve the same problem, just for different frameworks. But it's the same idea of how to like visualize stuff. And so, you know, you're solving that with Conan, and then VIPM is now solving it with Dragon, and there's some other solutions that were out there. There's the G package manager. And
we try to put parts and pieces together to solve a problem and not reinvent the entire thing. So I'm always in favor of using existing stuff.
Yep.
I also like using a lot of small tools that help me keep my workflow well, or that help me improve my IDE experience. I think the developer experience or your working experience has to be nice.
Yeah.
Don't switch too much windows or stuff like that.
That definitely comes from, well, I don't know if it comes from Fab, but Fab is definitely very big on the developer experience. That's one of her things when she says about decommission. She's like, it's all about making things easier for the developer and making the workflow easy. And
keep your mind focused on what you have to do.
Yeah, the less you have to worry about the minutia stuff, the more you can focus on the big picture. I think she mentioned that in her presentation today. So
because
I forget what it was about.
The package management and Conan is just a small part of our entire flow. And now we use Fork to do our Git as an IDE for Git.
Yep.
But it's more than that, because we implemented custom commands and we can do almost everything from that window. We got a nice view on the Git history, and we can trigger those commands.
So the custom commands, I haven't used Fork much. I've played around with it. The custom commands, are they shell commands then, or are they like, do you call GCLI and do everything in LabVIEW, or how does that?
I created some shell files and then that calls a Python script which calls GCLI.
Okay, yes.
Because there are some steps in between. The Python script grabs the text from Git, determines the next version to build, and then calls GCLI to actually do the build.
So curious then why you chose to evolve Python, like.
But that's only if we do builds, because if we use Conan, it's calling Conan directly.
Yeah, cool. So do you use Python in any other, like I know Python's like a big topic people are talking about. Do you use it anywhere else, or?
Not often. We use Python for some basic scripting stuff.
Yeah, I do too. It's always a toss-up whether it's easier to do it in LabVIEW or Python. I think
the Conan files are actually Python files.
Oh yeah, that's right. I do remember. I when you first started talking about this, I did a little bit of research.
Conan is a kind of a Python class, and then we have a extension class, which is something special in Python. And then actually your Conan file is a child of the Conan class, and it does things you want it to do. Cool. It invokes those methods on the extension.
Cool. So in addition to Conan, though, you're also using some tool called Artifactory.
But Artifactory is like a GitLab package repo.
Okay.
It's a repository for artifacts. So Conan stores its packages on that repo. It's like Git, but for binaries, it's much better.
Okay. Cool. Yeah, I've played around with the GitLab package repository a little bit. I haven't done a whole lot with it, but
it's where we store all our built artifacts like PPLs, packages, and executables.
So then it has like some web interface so you can go to download them if you want?
It has a web interface.
Yeah, so that's what I've used the GitLab API or the GitLab packages for. Like I have my CI script, build it and store in the packages thing and make a link to it in the releases. And then I have something in my project that looks and sees what the latest version is and will download it or something.
Yeah, like that. Except for Conan packages, because then you can use the Conan interface.
Oh, so you just use Conan instead. You don't have to go look yourself, and you tell Conan where to look, and it's
yeah. You can tell Conan to use those repos, and
okay. So Artifactory then is basically just like a storage solution.
yeah.
Okay.
And it has multiple, like you have for platform or project, you have a develop repo and the stable repo and the release repo.
Okay.
And then you can promote your artifacts from the one to the other as your process evolves.
Okay, and that mirrors like something you can get, like different branches or something?
Yeah,
okay.
that should be. We're working on that, because another thing is we also have the release management in Jira.
Yeah.
And we're still figuring out how to match those.
Yeah, that's something I want to play with mine too, because basically right now, the project I'm working on, they have like 5 test stations. And when I create a new release, I tag it in Git, I push it, it builds it, generates the package, everything. But it pushes it to everybody, and everybody gets, when they start the program, they get thing that there's a new release. It would be nice to have like a tag on there that says this is the beta release or whatever. And like one of the 5 machines could be subscribed to the beta channel, and it would get the beta, and we would download it there first and run it, and then, okay, great. And then just take the same release and just mark it as like
in Artifactory, you can set attributes or properties on your artifacts. So I think that's a way of tagging stuff.
Yeah, well, I think in the GitLab package repository, you could edit the description or something. You can just add like a tag in there that says like hashtag release or hashtag finish final or
that
whatever,
would be
or beta
possible.
Or however you want to do it. Yeah, I have to play around with that. I mean, so far it hasn't really been an issue, because like, they have several test heads and they know not to upgrade them until we've tested it on the one, and like then they just upgrade it. But
so for us, Conan solved the problem of not having system-wide dependencies, but per project, and we don't have to do all the VIPC stuff, because otherwise you have to apply this VIPC, oh no, we're changing project, apply another VIPC.
So I'm curious how you do releases, because I was listening to Jorg's presentation, and he was talking about how like, we don't want to deliver 10 exes to our executable in one day, and I totally get that. But like from my point of view, what I do is I make as many releases as I need every day, and the end user, when they start up the program, it says, hey, there's a new release and here's all the new features, and if you want to install it, great. And so if I make 3 or 4 releases, like the next time they reboot the computer, they just see the most recent one, and so like, I don't have a problem with releasing more often than what my customers install it.
Well, there's a step in between, because we merge to our develop branch, and then we get a test build.
Okay. And then you test the test build on the actual hardware.
And then when it's actually good enough to go to the customer, it's merged to the main branch, and then it's released and put on the well, in Artifactory you have those 3 different repos. So you go from develop to stable. Develop is what the developer tests. Stable is what the test engineers test. And then when it goes to the release repo, that's the only repo the customer sees.
Okay. See, for mine, it's kind of different, because mine, like, it's a research lab. So, like, if they get something in between, it doesn't work. Like, and the experiments they're doing, they're not like, it's not like a destructive experiment where they're like destroying something and like, oh, it's costly to rerun it. Like, they're measuring electron sources or something, and they turn them on and they measure some parameters. And if the measurement software screws up, they just shut down, roll back to the previous version and run it again, and it's not a big deal.
For our products, there can be many customers using it or downloading it, so it has to be really released, and you put it on the internet on a repo. So
that was one of the things that I think Fabiola and Jorg did really well of describing like how it can be situationally dependent and stuff. Sometimes I feel like I had a conversation with Jorg before where I was like very dogmatic of like, Git flow is an anti-pattern, don't use it, like blah, blah, blah. And I think that was a little bit too strongly worded, perhaps.
Yeah, we're somewhere in the middle. We're not using the real Git flow, but it's more than just a trunk.
Well, I think like the real key is like, if you're using branches, you really want to avoid long-lived branches. And as Jorg said, like that's like a red herring, because like what's a long-lived branch? But like, the longer it's open, the more commits you make on your branch, the more commits you make on the other branch, the more chance there is for conflict.
But you also have to do what works for your team.
But I'm also like, if your goal is to create really short branches, at some point, like if they're really short, like 1 or 2 commits, why create the branch to begin with? Because like to me, it's like part of the idea of branching, right, is everybody's in their own sandbox and they can make changes and not affect people.
Yeah.
But if you believe in the continuous integration thing, it's like everybody should be playing in their own sandbox so that all the changes are constantly getting integrated. And it's like a balance.
That's what we do. Every developer creates his branch.
Yeah, okay, yeah, this is interesting.
It's in his sandbox.
Mm-hmm.
But for a feature, that sandbox needs to merge back to the develop branch in a short-lived term.
Yeah.
But then afterwards, after that feature, for a new feature, goes back to his own sandbox, and it's short side turns on the same branch every time.
Yeah, see, that's totally reasonable. Yeah. No, that's cool. And you're not the only one I've heard of do that branch per developer. That's a fair. I mean, it's not like super common in the LabVIEW world, but
it's something we picked up from our colleagues that do Python.
Yeah, I was gonna say, in other like ecosystems, I've definitely
they do it like that, and they said, well, everybody else is doing it. Can LabVIEW developers also do it like that?
Yeah. Well, I think like there's a book, the book with the bat. It's like the O'Reilly book, and it has a bat on the front. And when it talks about it, it definitely talks about like Amy's branch, Bill's branch, Charlie's branch, or whatever. And so that might be where everybody picked that up from, because that book's pretty old. And so maybe that just came out, and everybody looked at that and said, "Oh, each developer's got their own branch. Great, that's what we'll do."
We tried it. It works for us, and it's also the people that work with Git are able to understand the workflow, and we haven't had problems with this workflow. Cool. So
do you ever run into like crazy merge conflicts, or is it pretty easy to avoid those?
We have maybe 1 or 2, but then it's like Fab told on library files or project files.
Yeah, it's
so as long as somebody is responsible for those, I think it's very rare that you have to merge a VI, because people work on different modular stuff in the project. If people work on the same project, it's on different parts.
So here's an interesting thought that I've had, right? Like, so Git flow and a lot of the stuff is built around people working in parallel. And we design our code to be easy for people to work in parallel by making it very modular. And okay, that's good design in general to make things more modular, but like, are we doing that because it's good design, or are we doing that because it makes it easier for people to work in parallel? And if we do it to make it easier for people to work in parallel, is working in parallel the most efficient way?
Also good to reuse parts.
To make it more modular.
Make it more modular.
Yeah, in general, modularity is a good thing.
To distribute stuff. So. The code we had from the past, which like 20 or 30 years ago was created, was a big toolkit with a lot of applications, but everything was one giant block, and the customer got a nice application with a lot of sub-applications.
Yeah.
But we moved away from that, and there need to be separate applications because you want to deploy them separately.
Yeah.
Not every customer needs every application in your toolbox. Another thing is, when we were working in SVN or later on in Git in such a big repo, then people are working on different tools, but they might touch the same common VI, and then we had some problems. But we
had that problem actually at Westinghouse, because we would do we had all our stuff in one SVN repo, right? And we would like freeze one project and say, okay, we're going to test it, and nobody's allowed to add anything to that. But people would keep adding the other ones, and the revision number kept adding. And so like we froze our revision 100, and then when we made one more commit, it was like revision 200 or something. And people were like, why is the number jumping so high?
That toolbox contained a lot of applications, like a couple of hundred applications. And we also extracted out common parts in packages. So as reuse code, and we have over 100 reuse libraries internal. So.
But from a business point of view, though, if you have that big monolith application that does 10 different things, it's probably a much better business proposition to have 10 different things that you could then sell. And then people can pick and choose, and you can have lower price points. Because otherwise you got to sell them everything and like it's super expensive and maybe they only want two things. And...
Also as a business, from a business point of view as well. As a software engineer, I tend to go with the first two arguments. Keep it modular to reuse it and to work in parallel.
No, so some of the people in the mastermind group, I know Kevin has played around with mob programming. Did you play around with it too? Or
we did some experiments in the mastermind group, but we didn't do it at work. No.
Okay, because I think Casey said he had also experimented with it, but he wasn't like quite convinced. So
I didn't do any other experiments.
No, it would be very interesting to see because like in the broader software community, I think there's a movement to do more mob programming. I don't know how much it's caught on, but
it takes a change of mind.
Yeah, so that's a lot. It's very much a paradigm shift.
Yeah.
And like management sees like, 10 people working on one problem versus 10 people working in parallel. Oh, well, the 10 people working in parallel must be faster. And I'm not convinced that's true, but I don't have any evidence to back that up yet. So
it's not only about the speed, it's also about sharing the knowledge and having backups for your people. Because if that one guy is very fast, you have it. The day he isn't there, somebody else, then you lose the time.
Yeah. Also, I'm thinking like, and this is just a thought experiment, but like if you have a mob of like 5 or 6 people, doesn't matter if one guy goes on vacation for a week, right? Because 6 or 5 people, like the difference in the output of the mob is probably small, so you don't notice. But if that one guy is working on a key feature and he disappears for a week and comes back, then everything else stalls out.
But when we did the experiment with mob programming in the mastermind group, it was also on a very easy advent of code puzzle. So it might not be representative for how do you do it on a daily basis.
Well, that's why I really want to find a big company that will let me like come in and experiment and run mob programming. So if anybody out there is listening and wants to do that, come see me because I would love to talk to you about that.
But there was a book you recommended about mob programming or some article? It was...
I've recommended a whole bunch of stuff. I don't...
but it was very nice.
Okay.
So, but it was a good experiment to do, and when I can, I'll try to pick it up or at least pair program.
Yeah, I mean, I do a lot of pair programming because often like I'm consulting with people, and it's just easier to do the pair programming thing, and I found it works actually really well over Zoom. It's like just Zoom and share screens and go back and forth, and I quite like it. I mean, I find it's interesting. I find one of the things that is interesting, you would appreciate this, is like watching other people program and just seeing their style and how they navigate things and like the shortcuts they use or don't use. Like, because I know you're big on the shortcuts, right?
I did the presentation on shortcuts and the small booklet.
There's a link on my website somewhere under resources, something about LabVIEW shortcuts that came from Stefan.
I talked about it with someone yesterday, and it's in the menu on your website. It's straight there. So
I know. Yeah, it's really cool. Yeah, it's like a 3-page pamphlet or 4-page pamphlet.
It's 8 pages.
8 pages. Okay, Well, I knew it was a lot. I couldn't remember a lot.
There are a lot of
it covers all the built-in ones, and then there's a bunch of add-ons that you can get from various
from the community.
Communities. Yeah, that's really cool that the community has shared all those things.
And it's about the native LabVIEW ones, the quick drop ones, and the right-click plugins.
Yeah. So I have a question on that. Like, do you remember like the JKI right-click plugin framework? Did that just go away when the LabVIEW introduced its own right-click thing? Is that kind of what happened?
I remember it. I haven't played around with it. So.
Yeah, I just remember like they had their own thing that was some special thing that you could install and they would let you right-click stuff. And now I think it's just built into Lab. I don't know. Tom would probably know that. Tom is up on all those things.
Yeah. But also not only from watching people program, because then you can see how they click or maneuver through the code. But also from watching other people's code or solutions to a problem.
Yeah, their thought process.
I learned a lot from last year's Advent of Code.
Yep.
Just seeing a simple question or problem and seeing the difference in solutions. Cool. That was a great thing.
Yeah. So tell us a little bit more about the Advent of Code.
Well, Advent of Code is a yearly programming puzzle. It starts on the 1st of December, and every day until Christmas you get a puzzle, which you can solve by programming something. It's actually 2 parts. So once you solve part 1, you get a more complicated question that can be solved with the same logic. And you can solve it in any programming language, but you also can create your own scoreboard and invite your friends. So I asked people from the LabVIEW world, let's do it in LabVIEW, and then I'll add you to my scoreboard. So we were about 30, I guess, last year that tried to solve some of those puzzles in LabVIEW, and then the first one gets the highest score and so on.
Yeah.
And then Casey also set up a Discord server.
Yep.
So we not only shared our solutions, but we also discussed stuff.
Yeah.
And it was very nice to see how other people find different solutions.
Yeah, so I've tried that in the past, the Advent of Code. I was trying to learn Python, and so I tried it in Python a couple of years ago. And then last year I did it in LabVIEW. And I was actually surprised. I learned quite a bit about LabVIEW. And
you still learn a lot.
Data structures and manipulation stuff. This year,
And
I
a
think
lot of new stuff because maps and sets.
Yeah, they came in really, really handy. And also regex came in very, very handy. I was surprised. So yeah, it gave me a lot of ideas for where I could use that in the future.
Yeah. It's the small nuggets that you get out of there. Yeah.
That's cool. Yeah, this year I think I'm going to join your group just so I can see all the LabVIEW submissions, but I kind of want to try to do it in Python again because I'm trying to get more.
And it tends to take time, especially after a couple of weeks when the puzzles get harder.
Yeah, there is that. Yeah, they start out really simple and it might take like half an hour. And then by the end, some of them, you can spend several hours easily on them. I mean, it's one of those things where I feel like a lot of them have like a trick, there's like a computer science solution, like there's some algorithm. And if you know the algorithm and you go look it up, then you can go.
Or sometimes it might be a mathematical algorithm or. And we're using LabVIEW, so sometimes you have to find a way to solve it in LabVIEW.
Yeah, and there's some interesting little twists. Some of the things like I-32s overrunning and stuff, like little things that you need to know about.
Or a couple of years ago when we didn't have interfaces yet, you couldn't do some multiple inheritance stuff. Or
The one year was very interesting. The one year I tried to do in Python, it was, I don't know if you remember, it was like the microcontroller. Do you remember that? Or like it was like a compiler.
Yeah, but that one kept on
adding on to the
the other days.
Like last year, each year was pretty individual. Yeah. The year before was definitely built. And that one, I definitely did a lot of inheritance in Python, a lot of classes, because it just made more sense. In LabVIEW, that would totally make sense to do it with classes.
And another thing that I also learned a lot about doing this was recurrency.
Recurrency, yes. No, I definitely used some recursive solutions last year in LabVIEW. And it's one of those things that like, I know it's in my toolkit, but I very rarely use it. I very rarely reach for it.
By doing it like that, you practice it once a year.
Yeah, but also too, like I find often I tend to reach for the iterative solution because like most of the recursive problems, you can also do it iteratively. Yeah. So I tend to reach for that more, but definitely practice some recurrency use.
But that's a good way of, besides your normal day job, keep on learning by trying stuff out.
Yeah, and also too, like the idea of like efficiency and stuff, because some of the problems, like there's a brute force way to solve it, but it just takes like an hour or at least a couple minutes. And then there's like a more elegant, efficient way. And just learning in LabVIEW which structures and which actions are very efficient.
And that's usually the difference between part 1 and part 2 of the puzzle. Because part 1 is possible to brute force, but part 2 will take forever.
Yeah. Cool. So that's very interesting, right? So you mentioned it's a very good way to experiment. So part of the point of the podcast is to encourage people to experiment. And part of that is normalizing what some people call failure, right? So you try something and it doesn't work out exactly the way you want. And I want to turn that conversation to, okay, I tried something, it didn't work. It's not a failure, but like I learned something. So can you think of a time when you like tried something I mean, it doesn't even necessarily have to be LabVIEW, but where you tried something and it didn't work out how you thought, and what did you learn? It can be something little.
Yeah, I think it wasn't a little thing. It was rather a big thing. But we had to do some refactoring on a big project, and instead of refactoring, doing only the refactoring, we also wanted to improve and add some features. So, and then in the end, it took more time than we expected. It didn't work out as we expected. So, yeah, what I learned from that is, stick to the requirements, because don't want to do too much, and deliver the minimum viable product first, and then start with improvements or adding features.
Yeah, so separate the adding new features from the refactoring stuff.
Yeah, and deliver first what was asked instead of doing too much at the same time.
Yeah, no, as software
Taking
engineers, we
small
often have
steps.
that. We see like what's possible, and we're like, oh, we could add this feature and stuff, right? That just starts down a really big rabbit hole, because you could always add more features.
Yeah, and taking the small parts to your minimum viable product.
Yeah.
It's also what JIPA always says.
The small steps,
small
many more much smaller steps.
Work in what he calls spikes.
Yeah.
You try something, you keep on trying, because usually it won't work on your first try. And then when you finally get to your solution, throw all that history away.
Yeah, and consider that the learning.
And consider that the learning, and then implement the right stuff without taking all the history of your
and do
trials.
It in really small steps. And no, I very much like that's like one of my core philosophies. You combine that with having really quick feedback, right? Because if you do the spike, you need to have some set of tests or something.
I really like the idea of doing spikes.
Yeah, and throwing stuff away. I feel like we're always afraid to throw stuff away. Like I inherit code bases all the time, and they've got disabled structures everywhere, and I'm like,
but that's history.
If it's disabled and it's never been there, like, why not throw it away? You could always get it back if you want it.
It's history that you're dragging with you that you're probably not going to use anymore.
And you're dragging it around in the Git history anyway. So why does it need to be there? It's a reason
why it's disabled. So probably it's some fail
or dead code too.
It's okay to have this failure, learn from it, but throw it out. And failure is never the goal to fail, but you should be prepared that something can fail. And prepared to learn from it. Also know how to learn from it, or know how to debug stuff, because I've noticed that's quite a skill.
Figuring out what went wrong or why something didn't work.
If it fails, it's okay, but you gotta know how to learn from your failure, or how to debug the thing that doesn't work.
Yeah, debugging is definitely its own lost skill. Some people are really good at it, and some people are really bad at it.
And then also something that Fab said is like, some people have like 10 years experience in LabVIEW, and some people have like 10 times 1 year experience, because they keep on repeating that same stuff, and then especially in debugging, I guess.
So I guess the moral of all that is that, quote, what most people call failure is okay as long as you learn from it. But if you keep repeating the same thing over and over again, like, what was that? Like, the definition of insanity is doing the same thing over and over again and expecting different results, right? So if you do something and it doesn't work, that's fine, but change what you're doing a little bit and try something slightly different, instead of just keep beating your head against the wall.
Learning from it.
Very cool.
Improving yourself.
No, this has been a great conversation. I really enjoy it. I wish we could keep going, but we do have some time constraints. And thank you very much. Hope you enjoyed the conference. It's been a great time. I quite enjoyed it. So looking forward to next year. And sometime you have to come join us in Boulder.
Hope I can.
All right. Thank you.
Okay. Thanks for inviting me.
Thanks. That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment, so you never miss an episode. And remember, small steps and quick feedback are all you need. Catch you next time.